Imagine for a second that you were sitting inside a highly capable, multi-million-dollar machine. I mean, the engines are humming perfectly.
Right.
The navigation systems are flawlessly tracking your route. The autopilot is executing literally every mathematical parameter it was programmed to follow.
Yeah, the machine is functioning at absolute peak performance.
Exactly.
Exactly.
But the humans operating it, they're quietly, invisibly slipping away.
It is just a profoundly chilling scenario. I mean, we are so conditioned to that narrative of, man versus machine, right?
Oh, yeah. That
Like a piece of technology breaks down and the humans have to heroically step in to save the day. But what happens when the machine does exactly what it's supposed to do and the biological component, the human being, just slowly powers down?
Welcome to the deep dive. Our mission today is to unravel a terrifying aviation mystery, and we are relying on an incredibly detailed, comprehensive breakdown from the YouTube channel Curious Pilot.
Which is a fantastic source for this kind of granular detail.
It really is.
Yeah.
So we are looking at the genuinely perplexing disappearance of Flight VHSKC, which was an Australian Beechcraft Super King Air 200. We're going back to September 4th, 2000.
Right.
And while you, listening to this right now, might not be flying a twin-engine aircraft today, the lessons here are universally applicable.
Completely.
We are fundamentally looking at human biology, the insidious nature of system design flaws, and how, tiny missing details can cascade into these catastrophic blind spots.
Yeah, and to understand just how bizarre the end of this flight was, we first have to look at the beginning. It's a warm spring afternoon in Perth, Western Australia.
Nice weather.
Perfect weather. We have a chartered flight heading to a mining town called Leonora. On board are 7 passengers. These are mining company employees heading back for their shift, and 1 pilot.
Okay, let's unpack this by establishing the baseline of that pilot, because his background is the very first piece of the puzzle here.
Yeah, it's crucial.
He was 50 years old, holding an air transport pilot license. He had over 2,000 flight hours, with 138 hours specifically on this type of aircraft, the King Air 200.
So this was absolutely not a novice.
Not at all. He was actually known in the community for his incredibly professional, cautious approach to flying. Witnesses who spoke with him right before the flight reported he was happy, physically well, and highly methodical.
And that methodical nature is vital to remember for later. I mean, one of the passengers actually asked to sit in the front right pilot seat just to observe the commercial flying operations.
Which is pretty cool, honestly.
Yes, for sure. And the pilot obliged, but he gave the passenger a strict, thorough safety briefing, explicitly outlining, what not to touch.
Right, keep your hands off the controls.
Exactly. Then he moves on to the aircraft itself. Because it's a quiet afternoon at the airfield, he holds off on his run-up checks until they are at the holding point for runway 21, and he runs through his checklist flawlessly.
Think of this checklist not just as a routine, but kind of like a computer's boot sequence or a perfectly standard daily commute. Every single physical switch, every gauge check is a line of code.
That's a great way to look at it.
Right. Because if you skip one, the program might still load, but eventually it's going to hit a fatal error, and he skips nothing. He checks the auto feather system, which automatically adjusts the propellers to reduce drag if an engine fails.
Right.
He checks the rudder boost system, which physically helps the pilot control the aircraft's yaw in that same engine failure scenario.
Yeah, all standard safety checks.
He double-checks with his passengers to ensure everyone is ready. At 18.09 local time, he pushes the power levers forward. The 2 Pratt & Whitney engines roar to life, and they take off perfectly. 0 red flags.
And that context right there, that is so important. When investigators look at a disaster of this magnitude, the first things they look for are intentional foul play, severe mental distress, or gross negligence.
Like someone making a terrible mistake right out of the gate.
Exactly. By establishing that this was a textbook departure by a healthy, seasoned, cautious pilot, investigators can immediately rule out an entire spectrum of human error. It narrows the focus to something systemic or something physiological.
Right. So as they climb out of Perth, the pilot is communicating completely normally. His responses to Perth departures and then Melbourne Center are crisp.
Normal tone, normal pacing.
Yep. At 18.15, he's asked if he can hit a specific altitude by a certain distance. He quickly replies, affirmative. He is cleared to climb to his final cruising altitude, which is flight level 250, so that's 25,000 feet.
Which is high up there.
Yeah. He engages the autopilot, Dials in the altitude, sets his instruments. Everything is totally standard.
Until 18.20. That is the exact moment the anomaly begins. Air traffic control gives the pilot a slight shortcut, like a direct routing to a waypoint called Point Deborah.
Okay.
The pilot acknowledges this clearly. He says, direct Deborah. And that is his final, clear, fully coherent response to anyone on the ground.
Wow. And the timeline from that moment on gets just incredibly eerie. Air traffic control is watching his data block on their radar screen. They see the King Air approaching its assigned altitude of 25,000 feet.
But it doesn't stop.
It doesn't level off at all. It blows right past 25,500, then it hits 26,500. It is continuing to climb. So air traffic control keys the microphone and asks Flight Sierra Kilo Charlie to verify their altitude.
And the response they get back is not that crisp, professional voice from just 5 minutes earlier.
No, it's totally different.
It is sluggish. The words just drag. The pilot says, stand by, checking.
And over the next 8 minutes, the radio crackles to life 8 separate times. But it's not a voice. It's an open mic transmission.
Right, the button is being pressed, but nobody is speaking.
Exactly. Whoever is pressing the push-to-talk button isn't saying a single word. ATC just hears heavy breathing. They hear faint tones in the background. They hear the drone of the aircraft's engines.
It's just chilling.
And a little later, there's another open mic transmission that lasts for almost 4 entire minutes. Just breathing. ATC is frantically clearing out a massive block of airspace, telling all other planes to stay away. They're asking the pilot to squawk ident.
Yeah, and for anyone unfamiliar, squawking ident is a very basic, fail-safe way to communicate. ATC is asking the pilot to reach over to their transponder and press a single button marked ident.
Just one button.
Just one. When you press it, your plane's radar blip literally flashes on the air traffic controller's screen. It's a way for a pilot to say, hey, I hear you, but I can't talk right now. The controller asks for this simple button press, and they get absolutely nothing. The radio equipment is working perfectly. The human operating it is degrading.
Wait, hold on, though. If the pilot is physically holding the microphone button down on the yoke for 4 whole minutes and breathing heavily into it, he clearly knows something is wrong.
You would think so, yeah.
Why doesn't he just say the word help? Or better yet, just reach over, disconnect the autopilot, and point the nose of the plane down to a lower altitude?
What's fascinating here is the insidious nature of the physiological breakdown happening inside his brain. We are talking about hypoxia oxygen starvation. Hypoxia does not work like a light switch where you just suddenly pass out. It fundamentally and systematically degrades your higher cognitive functions first.
So he's awake, but his brain is basically misfiring.
Exactly. His brain might recognize a vague, terrifying sense of dread. It might recognize that a procedure is required, which is why his muscle memory has him physically squeezing the radio button on the yoke.
Oh, wow. Muscle memory.
Yeah. But the neural pathways required to form language, to physically articulate words, or to execute a complex multi-step motor function like disengaging an autopilot and flying a descending turn, those pathways are actively shutting down.
That is horrifying.
It really is. He is trapped inside a body that will no longer obey his commands and a mind that can no longer process the exact nature of the danger it's in.
So while this silent, invisible struggle is happening in the cockpit, the plane just keeps climbing. It passes 32,500 feet and drops off the primary radar. I want to paint the visual for you, listening right now. We have a multi-ton aircraft, acting as a ghost ship, cruising unguided at hundreds of miles an hour across the vast, pitch-black Australian outback.
It's almost hard to picture.
Yeah. Australian search and rescue scrambles nearby planes. They manage to divert a business jet to intercept the King Air at an altitude of 34,300 feet.
Put yourself in the cockpit of that business jet. They maneuver their aircraft alongside the King Air in the absolute darkness of the night sky. They look over, and the external lights on the King Air are flashing perfectly.
Like nothing is wrong.
Like nothing is wrong. The navigation lights, the strobe lights, they are all working. The plane is perfectly trimmed, flying straight and level on a steady heading of 050 degrees. From the outside, it is a picture-perfect flight.
But when they try to peer through the windows into the cabin, it is completely dark. There is no movement. It is just a machine, perfectly executing its last set of instructions, carrying 8 unconscious or already deceased people through the stratosphere.
And the business jet eventually has to break away because it runs low on fuel, but the King Air just keeps flying for hours. It eventually starts a very slow descent, coming down to about 25,000 feet.
Still completely unresponsive.
Totally. Later that night, 2 more aircraft are tasked with intercepting it. They pull up alongside this silent plane, cruising at just over 200 knots, and they fly formation with it for an hour and 35 minutes.
An hour and a half of flying just feet away from this plane. The chase planes are desperately trying to hail the King Air on the guard frequency.
Which is 121.5 megahertz. It is the universal distress channel. Every single commercial and military aircraft monitors this frequency.
It's basically the 9/11 of the skies.
Exactly. They are broadcasting on this channel, flashing their landing lights, doing everything physically possible to visually get the attention of anyone inside, and they get absolutely nothing in return.
The plane has now flown completely across the Australian continent. I mean, we are talking about crossing a landmass roughly the size of the continental United States, going from the southwest coast near Perth all the way toward the northeastern coast.
But because it is a machine bound by the laws of physics, it has a strict, unavoidable time limit. At 23.10, passing 5,000 feet near a remote town called Burketown, the fuel runs out. Specifically, the left fuel tank runs dry first.
And this is where the mechanical reality of the crash takes over.
Yeah.
When that left engine starves of fuel and dies, it sets off a rapid, violent chain of events.
Yeah.
Because the pilot is incapacitated, he cannot engage the auto feather system.
Right. Remember that specific checklist item he meticulously checked on the ground before takeoff?
Yeah, the one that adjusts the propellers.
Exactly. When a jet engine dies, it just spins down. But when an engine dies on a turboprop plane, the massive blades of the propeller, if left in their normal position, hit the oncoming air flat.
That sounds bad.
It is. It creates a massive wall of aerodynamic resistance. The auto feather system is designed to twist the blades so they slice through the air edge-on, reducing that drag. But without the pilot there to manage the system or secure the dead engine, that left propeller instantly turns into a massive disk of drag.
So you essentially have thrust coming from the right engine and a giant parachute deploying on the left engine.
That's a perfect way to describe it.
The autopilot, which has been flying the plane perfectly for hours, tries to fight the physics. It uses the rudder and ailerons to hold the heading, but it simply does not have the control authority to overcome that immense asymmetrical force.
It's just impossible.
The aircraft violently yaws, snaps 90 degrees to the left, rolls over, and rapidly loses altitude. It hits the ground and disintegrates on impact. There are no survivors.
Just think about that for a second. Hours of perfect silent flight, completely unresponsive to the outside world, ending in sudden, absolute violence in the pitch-black outback. It is an incredibly heavy reality to sit with.
It really is.
Yeah.
And when the investigators arrive at the crash site in the remote outback, they are faced with a monumental obstacle. This King Air was not equipped with a flight data recorder.
No.
It did not have a cockpit voice recorder. The black boxes that usually give us the answers were simply not there. How do you piece together a puzzle when all the pieces have been pulverized and you have zero internal data?
If we connect this to the bigger picture, investigators essentially had to perform a medical autopsy on the flight using only secondary symptoms. First, they look at the radar track. The plane flew perfectly straight for hours before running out of fuel.
Which means the plane itself was physically intact.
Exactly. That immediately rules out a catastrophic structural failure, like a wing snapping off or an explosive decompression that destroyed the flight controls. So they turn to the ATC radio tapes. They analyze the slow, slurred speech. They listen to the labored breathing.
The open mic transmissions.
Right. They look at the total inaction of the passengers in the back. By looking at what wasn't happening, they confidently diagnosed the flight itself with hypoxia.
Which brings us to the core of the mystery. The why. Why did a perfectly functioning aircraft starve its occupants of oxygen? The investigators determined the cabin never pressurized.
To understand how lethal this is, we need to talk about the time of useful consciousness.
Okay, what's that?
If a cabin fails to pressurize as you climb through 25,000 feet, you only have about 3 to 5 minutes before you are physically incapable of saving yourself. At 30,000 feet, that drops to under 2 minutes.
Less than 2 minutes.
Yeah. And I can speak to this from personal experience. I have actually been through high-altitude hypoxia training in a controlled military-grade altitude chamber.
Wait, really? What does that actually feel like? Because, movies always make it seem like you're gasping, clutching your throat, and choking for air.
It is the exact opposite, and that is what makes it so incredibly dangerous. You aren't gasping at all. Your body doesn't actually measure the lack of oxygen. It measures the buildup of carbon dioxide.
Oh, interesting.
Since you are breathing out carbon dioxide perfectly fine at altitude, your lungs don't trigger that panic response. You don't feel out of breath. You just feel mildly confused, maybe a little euphoric, like you've had a few drinks.
Wow.
During my training, the only physical symptom I had was that the skin on my neck got a little bit warm and flushed red. That was it.
Just a warm neck.
That's it. If I hadn't been looking in a mirror specifically trained to watch for it, I would have just quietly fallen asleep. It is completely painless.
That is terrifying. So in the wreckage of this King Air, the investigators are digging through the pulverized instruments, looking for the life support systems. They need to figure out why the plane didn't pump air into the cabin. And they find the bleed air valves.
Right. And let's explain how that works real quick. Jet turbines compress massive amounts of air to generate thrust. To pressurize the cabin, some of that hot, highly compressed air is literally bled off the engines, passed through a cooling system, and pumped into the fuselage to inflate it like a rigid balloon.
Which keeps the air thick enough to breathe at 30,000 feet. So the investigators find that the airflow valve in the left engine, the valve that provides that bleed air, was in the closed position. The right valve was open.
But here's the thing. Even with only one valve open, the system should have been able to pressurize the cabin up to 31,000 feet.
Right. So investigators look deeper. They suspect the dump switch might have been left open. A dump switch is exactly what it sounds like. It's a manual valve designed to rapidly dump the cabin air outside.
You'd use it if there's like an electrical fire filling the back with smoke and you need to clear the air instantly.
Exactly. If that switch was accidentally left open, any air being pumped in by the right engine was just venting straight out into the atmosphere. The crash damage was so severe they couldn't physically confirm the exact switch positions, but it's the most likely scenario.
And the obvious question is, how does a meticulous pilot who ran a flawless run-up check miss these switches?
Yeah, how does that happen?
This is where human psychology and checklist fatigue come into play. It is a phenomenon known as confirmation bias. When you look at a switch panel that you have verified thousands of times in your career, your brain heavily expects those switches to be in their normal, correct positions.
You see what you expect to see.
Yes. You can look directly at a switch that is OFF, and your brain will literally perceive it as on-in because that is the reality you anticipate.
What they did firmly confirm from the wreckage was the terrifying state of the oxygen system. In this specific aircraft, oxygen did not flow automatically.
Which is a huge detail.
Right. In a commercial Boeing or Airbus, if the pressure drops, yellow rubber masks automatically fall from the ceiling and oxygen starts flowing. In this King Air, it required manual activation.
Yeah.
The pilot had to physically reach up and pull a left handle to start the oxygen flow for the crew, and forcefully pull a right handle to drop the masks for the passengers.
And when they examined the debris, they found that the passenger masks had deployed, but there was zero evidence they were ever worn. The straps weren't stretched. No one in the back ever put them on.
So tragic.
The pilot's mask was connected to the system, but it was likely not used in time, if at all, because by the time the pilot realized there was a physiological problem, he was already too deep into the cognitive degradation to execute the multi-step process of securing the oxygen.
Here's where it gets really interesting and, frankly, infuriating from an engineering standpoint. How do you not realize the cabin isn't pressurizing before the hypoxia sets in? Doesn't a multi-million-dollar plane have alarms for this?
Well, it did.
The King Air did have an alarm. When the cabin altitude, the air pressure inside the plane reaches 10,000 feet, a warning activates. But the warning was just a visual light.
Unbelievable.
A yellow, high cabin altitude light illuminates on the instrument panel. There was absolutely no accompanying sound.
It is a profound design flaw based on a complete misunderstanding of human psychology under workload saturation. Think about what a pilot is doing as they climb through 10,000 feet. They are monitoring airspeed, adjusting engine temperatures, constantly talking to air traffic control, programming the autopilot, and scanning weather radar.
Their visual field is entirely saturated.
Completely. They are looking at dozens of moving gauges. A single silent yellow warning light can easily blend into the background noise of the instrument panel. It is neurologically invisible to a saturated brain.
It is exactly like having a fire alarm in your house that only flashes a tiny LED light but doesn't actually ring or make a sound right when you're incredibly distracted, cooking dinner, watching a pot boil, and talking on the phone.
That is a brilliant analogy.
You could be standing right next to the alarm, the house could be filling with invisible carbon monoxide, and unless you happen to look directly at that specific LED at that exact moment, you would never know you were in danger. I am just shocked that such a critical life or death warning was strictly visual.
And that shock was shared by the entire aviation industry, and this tragic flight became a massive catalyst for change. The investigation generated several major permanent safety recommendations.
Which is at least a silver lining.
Definitely. First, air traffic control emergency checklists were entirely overhauled. Controllers are now specifically trained to listen for the auditory symptoms of hypoxia.
Like the slurred speech.
The slurred speech, the delayed, confused responses, so they can explicitly command pilots to check their oxygen supply before they lose consciousness.
And what about the silent alarm flaw?
Crucially, recommendations were pushed for mandatory oral meaning audio warnings in high-altitude aircraft. If the cabin pressure drops, an obnoxious, impossible-to-ignore sound must blast through the cockpit.
Good.
You simply cannot rely on a human's vision when their brain is actively starving of oxygen and distracted by flying. Furthermore, training protocols were fundamentally changed. Pilots are now taught that the absolute first, non-negotiable step in any high-altitude anomaly is to put your oxygen mask on immediately.
Don't try to fix the plane first.
Exactly. You don't try to troubleshoot the bleed air valves. You don't try to read the warning panel to see what went wrong. You put the mask on, secure your oxygen supply, and only then do you figure out the problem.
So what does this all mean? The legacy of Flight VHSKC is the stark realization that the mechanical systems surrounding human beings must be engineered to account for our inherent biological vulnerabilities.
This raises an important question, doesn't it?
Yeah.
How do we design systems, whether in aviation, in modern medicine, or in the software we use every day, that actually protect us from our own invisible limitations? Engineers often build machines assuming the human operator is functioning at 100% capacity.
But humans get tired.
Humans get distracted. Humans suffer physiological failures and confirmation bias. A truly robust system has to assume the human will fail, and it must be explicitly designed to catch them when they do.
We are so conditioned to expect loud, obnoxious alarms when things go wrong. We expect sirens, flashing red lights, someone yelling. But think about the silent warnings in your own life, your work, or the technology you rely on every single day. We assume that if we don't hear an alarm, everything must be fine. But what happens when danger is perfectly comfortable? How do you know you're in trouble when the threat doesn't make a sound? Something to think about the next time you assume silence means safety. Thanks for joining us on this deep dive.